So today we are looking at the introduction to acid value, and basically we are going to look at rancidity. So rancidity. We'll start by looking at what rancidity is. So first of all, what we have to note is that rancidity is the development of unpleasant smells in fat and oils, which are accompanied by changes in their texture and appearance. Rancidity occurs when fats and oils are exposed to air, light, moisture, heat, or bacterial activity, and this results in an unpleasant smell, which is an off odor or flavor, taste, and texture of the lipids. Let's look at the types of rancidity. Rancidity can be classified into two major groups, and these are the oxidative rancidity, which is caused by fat oxidation, and hydrolytic rancidity, which is caused by the hydrolysis of fat. So let's take the one after the other and look at them. So we'll start by looking at hydrolytic rancidity. So first of all, what we have to note is that hydrolytic rancidity is the breaking down of fat or oil into glycerol and fatty acid in the presence of moisture and the enzyme lipase. So from the reaction over here, this is our lipid or the triglycerides, and this is in the presence of water, and this is enzyme. So what we can see here is that the enzyme lipase catalyze the breakdown of lipids in the presence of water by hydrolyzing the esters of the fatty acid to produce glycerol and free fatty acid, which are responsible for the unpleasant smell or odor of the lipid. And what you also have to note is that the other name for the enzyme lipase is triacyl glycerol acyl hydrolase. And one key thing that we have to note is that hydrolytic rancidity can occur in both saturated and unsaturated lipids. Oxidative rancidity. Oxidative rancidity is the oxidation of fat or oil to produce peroxide derivatives, which on decomposition produces aldehydes, ketones, and dicarboxylic acid, which are responsible for the unpleasant smell. And this occurs due to the oxidative addition of oxygen to the carbon-carbon double bond of the unsaturated fatty acid of the oil. And from this diagram over here, this diagram shows, or this picture shows, an oxidation reaction of lipid, which involves the oxidative addition of the oxygen to the carbon-carbon double bond of an unsaturated fatty acid to produce hydroperoxide and free radicals. And upon decomposition of the hydroperoxide produces aldehydes and ketones and acids, which are responsible for the unpleasant smell. And this is also another reaction here showing the oxidative addition of oxygen to the carbon-carbon double bond of an unsaturated fatty acid to produce hydroperoxide, which upon decomposition produces aldehydes and ketones and carboxylic acid that are responsible for the unpleasant smell. And what we also have to note is that oxidative rancidity is catalyzed by light, heat, trace minerals, and free radicals. So what we have to note is that lipid oxidation involves three main stages. And these are the initiation stage, the propagation stage, and the termination stage. So we are just going to pick them one after the other and look at what happens in each of the stage. So we'll start by picking our first step or stage, which is the initiation stage. The initiation stage involves the formation of lipid-free radicals. So what happens is that unsaturated fatty acid or triglyceride is catalyzed in the presence of either heat, metal ions, or light to form lipid-free radicals. So as you can see over here, this is our unsaturated fatty acid in the presence of either metal ions, light, or heat being catalyzed to form a lipid-free radical as seen over here. So where RH is in unsaturated fatty acid under UV light or metal ions or heat producing lipid-free radical stage. The next step involves the propagation stage. And this stage involves the formation of more free radicals. And these are the peroxide free radicals and lipid free radicals. So what you have to note is that in this stage, the lipid free radicals produced in the initiation stage react with oxygen molecules to form peroxide free radicals as this. So this is our lipid free radicals reacting with oxygen molecule from the atmosphere or from the surrounding to produce peroxide free radicals as this. Again, the peroxide free radicals produced here react with another unsaturated fatty acid to form a stable hydroperoxide and another lipid free radicals. So this is the peroxide free radicals produced at the first stage of the propagation stage, reacting with another unsaturated fatty acid to produce hydroperoxide and another free radicals. The last step or stage is the termination stage, and this stage involves the formation of non-radical products or stable molecules. So what happens here is that termination occurs when a buildup of these free radicals formed during the propagation stage react with each other to form non-radical products or stable molecules. And these are some of the reactions that occurs in the termination stage. So the first has to do with the peroxide free radicals produced reacting with lipid free radicals to form the stable molecule this. So this is our peroxide free radicals reacting with the lipid free radicals to form the stable molecule, and two lipid free radicals reacting together to form the stable molecule this. And also the two peroxide free radicals reacting together to form the stable molecule this and oxygen molecule. So this is a summary of the oxidation rancidity, which involves the three main steps. So as said earlier, the first step happens to be the initiation step, and this involves the formation of lipid-free radicals in the presence of metal ions, light or UV, and heat. The next step happens to be the propagation step, and this step involves the formation of more free radicals that leads to the formation of peroxide radicals, and lipid free radicals, and hydroperoxide, which upon decomposition produces ketones, aldehydes, and alcohols that are responsible for the unpleasant smell of the lipid. And the termination step, which happens to be our final step, involves the reaction of free radicals to form a non-radical product or stable molecules. So as you can see over here, these free radicals, so these lipid free radicals can react with this lipid free radical to form a stable molecule, and the peroxide radicals over here can also react with these free lipid radicals over here to also form a stable molecule. And also an antioxidant like ascorbic acid or vitamin C can also be introduced into the termination step to react with these free radicals over here to form a stable molecule. So this is just an illustration showing the three main stages of the oxidative rancidity. So some key points to note. What we first have to note is that the reaction of lipid oxidation continues until there is a depletion of oxygen, or when a fatty acid radical reacts with a stable antioxidant radical, or when two unstable radicals react. Also, the hydroperoxide produced in the propagation stage can undergo further reaction with or without the participation of other compounds to produce ketones, aldehyde, alcohols, and acids, which are responsible for the unpleasant smells of the rancid lipid. So these are some key notes that we have to take note of. Let us look at the other types of rancidity. So we have enzymatic rancidity, and this rancidity is caused by the action of enzymes, which lead to the formation of free fatty acid and glycerol, which are responsible for the unpleasant odor or flavor of the rancid food. The next is photooxidative rancidity. And this type of rancidity is caused by the action of light, which leads to the formation of free radicals, which are responsible for the unpleasant odor or flavor of the rancid food. And we also have microbial rancidity. So, and this type of rancidity is caused by the action of bacteria, which leads to the formation of unpleasant compounds. Factors affecting rancidity. So the first factor that affects rancidity is oxygen. So what we have to note is that the primary cause of rancidity is exposure to oxygen. And also, oxygen is more soluble in fats, which leads to food damages and oxidation by releasing free radicals. The next factor is microorganisms. Many microorganisms release the enzyme known as lipase, which leads to the hydrolysis of lipids. These microorganisms use their enzyme on food materials and destroy their chemical composition. The next is physical factors. So heat, light, and temperature play an important role in rancidification. Heat and light stimulate the process of oxidation and are the main sources to produce free radicals. Light also promotes the decomposition of unsaturated fatty acid. Heating foods at higher temperature also cause fats and oil to oxidize, leading to rancidity of unsaturated essential fatty acid. Example is the omega-3 fatty acid and the omega-6 fatty acids. The next factor is trace element. The rate of rancidity can be increased by trace elements like iron, zinc, manganese, and copper. And the last factor is the type of fat. So what you have to notice is that the more unsaturated the fat molecule is, the greater the tendency of oxidative rancidity. Vegetable oils, although unsaturated, are generally more resistant to oxidative rancidity than animal fat because they contain natural antioxidants. Vitamin E is a common antioxidant found in vegetable oils. Fish oils, on the other hand, are highly unsaturated and hence more susceptible to oxidative rancidity. Effects of rancidification on lipids. 1. The products of rancidity are toxic, that is, causes food poisoning. 2. Rancidity destroys the fat-soluble vitamins such as vitamin A, D, E, and K in food. 3. Rancidity destroys the polyunsaturated essential fatty acids like omega-3 fatty acid and omega-6 fatty acid. 4. Rancidity causes economic loss because rancid food or fat is inedible. Prevention of rancidity. One way to prevent rancidity is the addition of antioxidant. So first of all, what we have to note is that antioxidant is a molecule that prevents the oxidation of compounds. And what we have to note is that antioxidants function by interfering with the chain reaction. Thus, they do not stop the formation of free radicals but prevent their propagation. So as you can see over here, this is our antioxidant and this is our free radical cells. So what happens is that the antioxidant shares its electrons with the free radical cells over here to make it stable. So this is basically how antioxidant works in the presence of a free radical to make it stable. So the next point is elimination of oxygen, and this can be achieved by packaging under nitrogen, also packaging in vacuum, and packaging with an oxygen scavenger. So the next step to prevent rancidity is elimination of the sensitive substrate, and this can be done by replacement of polyunsaturated oils with less unsaturated oils such as olive oil or palm oil that are more stable. Next is decreasing the state of oxidation, and this can be done by storage at low temperature, example in a refrigeration. 2. Storage in the dark. 3. Use of fats and oil that contain low levels of oxidation promoters, example oxidized products and heavy metals, and the use of ingredients that are naturally rich in antioxidants. Let us look at how antioxidants works. So this is our antioxidant over here, and this is our free radicals or unstable or our imbalanced molecule over here. So what happens is that antioxidant works by sharing their electrons with free radicals to stabilize them, and these as a result prevent the free radicals from reacting with nearby fat molecules to cause their rancidity. So from the picture over here or from the diagram or illustration over here, the unstable molecule or our free radical over here in the presence of an antioxidant becomes a stable molecule, and this happens upon the addition of or the introduction of an antioxidant like vitamin C. And what happens over here is that the antioxidant stabilizes our free radicals over here by sharing electrons with it, and hence making it a stable molecule. So other antioxidants that can be used are, we have the BHA and the BHT. So these are other antioxidants that can be used in place of the vitamin C to reduce or to prevent rancidity. So what you have to note is that a molecule can function effectively as an antioxidant if one, it reacts with free radicals more rapidly than the free radicals react with lipids. Two, if the product of the reaction with the free radicals are not pro-oxidant. And three, if the molecule is lipid soluble. So let us look at an example. Vitamin C is used as an antioxidant because it is more readily oxidized than fats and oil. And also, when a peroxide radical is formed, vitamin C will donate hydrogen atoms to the free radicals to prevent its reaction with the nearby fat molecules. So, differences between hydrolytic and oxidative rancidity. So, hydrolytic rancidity is caused by the breakdown of lipids into its components. So that is the fatty acid and glycerol. So whilst oxidative rancidity occurs due to the oxidation of fatty acid chains, typically by the addition of oxygen across the carbon-carbon double bond of or in unsaturated fatty acid. 2. Hydrolytic rancidity occurs more rapidly in the presence of enzymes such as lipids and with heat and moisture, whilst oxidative rancidity process proceeds by the free radical mechanism catalyzed by light in the presence of heat or metal ions. In hydrolytic rancidity, the water present in the food and the high temperature increase the rate of hydrolysis to fatty acid. Whilst in the oxidative rancidity, the complex free radicals reaction produce a wide variety of products, many of which have unpleasant odors and taste. Thank you.